On Stockbox today, we welcome Mike Moles, the Technical Director of Kavango Resources. It's great to have you back. Mike, how are you doing?
Yeah, I'm fine. Thank you very much, Mark. Very
Good,
good.
good. Yes, so we spoke not so long ago, but of course,
Mhm.
Kavango have released an RNS this week where you say you've identified 4 targets that you selected by the 3D magmatic model developed by the company. And I think the plan is for me and you to have a longer podcast later in the week or early next week to actually discuss some of this in more detail.
Mhm.
But on this interview here, we'll keep it fairly short. So, what are the significance of these 4 targets, and why did you pick them?
Yeah, okay. Well, we had to sort of start somewhere. We've got a very large area. I mean, we're dealing with an extremely large exploration target generally. I mean, the Kalahari Suture Zone is 450 kilometers long by about 50 kilometers wide. And so part of our exploration effort has been to sort of narrow down our search area into those areas where there is the greatest amount of prospectivity. And that has sort of continued to a point where at the completion of the 3D magmatic model, which was, I think, completed in early September, we were able to identify in 3 dimensions where the Karoo intrusive gabbros are, and had a very good idea of their shape and their depth and so on, which is amazing. I mean, I'm just almost blown away by how brilliant this software is. That you can get in there, you can fly around inside the rocks, as it were, so you can see where everything is. But it's based on a certain amount of data that we collect from magnetic surveys, combined with and constrained by other data, in particular drill hole data, which from drill holes which were drilled some time ago, historic drill holes that give us a lot of magnetic data because we can test the magnetic susceptibility of these holes by running an instrument down the core, and that's been invaluable in being able to constrain the software so that it's sort of based in reality, as it were. So the objective was to try and find the deepest gabbros. So these gabbros are all sorts of different shapes, but I suppose the basic shape is a sort of trumpet shape, I would say, so that you get a sort of vertical part of the dike which is coming up. A vertical part of the intrusive which is dike-like. And that sort of blossoms out into a more horizontal orientation as it reaches up towards the surface. And it becomes more sill-like as the molten magma intrudes into and in between the various sedimentary layers. Now, we're pretty sure that if there is going to be massive sulfide mineralization, the sulfide material, as it's heavy, whilst the magma was still liquid, the sulfide liquid would tend to gravitate towards the bottom of the gabbroic intrusive. So we want to find the deepest parts of these gabbros, and by and large, the magnetic model has shown us where those deeper parts are. So the 4 areas that we selected are 4 areas where we know, first of all, that the intrusive gabbros are quite deep and therefore have a greater chance of accumulating massive sulfides. But we also are interested in how long they extend for. So we've picked out areas where we where it appears that these intrusives continue at depth, as deep keels over a long distance. And one of them, I think, is nearly 15 kilometers long. So these are quite large ore body, or not, or whatever we're talking about, intrusives. And so we need to try to identify massive sulfide conductors within those gabbroic intrusives. So we've picked out the four areas where it appears that that criteria is met.
Okay. And did you also use an historic drill hole to help you identify? Is that right?
Yes, that's right. Well, right in the middle of the area that we were particularly interested in, which we call the Hukunsi section, which is really the northernmost part of the Kalahari Suture Zone. There is a borehole which was actually drilled in, I think, 1983, if my memory serves me correctly. And the core from that borehole is still available. It's preserved very nicely in a government-owned core shed, not very far away, actually, from where we're working, in a place called Kang. And we were able to get it out. We, in fact, twice, I think, we've taken it out and sampled it, tested it for its magnetic susceptibility, re-logged it, and so on. So this has been invaluable, as I said earlier, to constrain the magnetic model, and also to give us an indication of what it is that we're looking at depth. This borehole goes down, I think, 460 odd meters. So it gives us a pretty good idea of the beast that we're dealing with.
Okay. And here's a question. What is petrography work? What is that?
Petrology is really it comes from the Latin, I think, petrus, meaning rock. So it's really the study of the rocks, and what different rocks are classified according to their mineralogy. So rocks are made up of minerals. So in the sort of scientific terminology, the petrology is the naming of the rocks, and the mineralogy is the naming of the minerals that make up the rocks.
Okay.
So there you go. A bit of education for you.
A little bit of education there. It's a word I haven't seen.
Geology.
Yeah. In the now.
So what we want to do now, in fact, tomorrow, our chief geophysicist, and who's also the managing director of our local company in Botswana, Hilary Gumbo, who's also one of the founders of Kavango, is going to arrive in Botswana to supervise and to assist in the conducting of these large loop ground EM surveys. And that is, that's a very exciting development. In fact, we managed to organise that rather quicker than we anticipated, which is great. I had at one time thought we weren't going to be able to do it until after Christmas, but we can certainly do the first of the four targets will be done. Will be started next week. Okay. It takes about a week to set it up and to undertake the survey. And that will be very exciting. The objective here is that, well, just to go back a little bit, when we did the airborne EM, the airborne EM was somewhat confused by conductive sediments, and in particular conductive sediments that contained brines, salt water in the groundwater, and which is quite conductive, and it meant that it was difficult to identify or to separate out or to distinguish between conductors that may have been massive sulfides, and conductors which we would call formational conductors. So the objective now is, now that we've got a good 3D model, we know exactly where the intrusives are. We're only interested in conductors that are within the Gabbro intrusives. So anything that lies outside of them are not going to be seen as being massive sulfide conductors. Okay. And in fact, if you find a relatively high-speed conductor within the Gabbro, there's very little else that it can be, because the Gabbros are quite tight. They won't allow very much water into them, and we're pretty confident that any high-speed conductors found within the Gabbros will be mineralization.
Okay, and these loop surveys, they work by sending an electromagnetic pulse into the ground that then can help you to visualize, almost like an ultrasound kind of thing.
Yes, that's right. I mean, it's a system that was developed in Australia, actually, for the very deep weathering profile that you have in Australia. As you probably know, Australia, what they often call it, the red continent, because all the rocks are very heavily weathered. And so you sometimes can go down, hundreds of meters before you get to any fresh rock. So the concept of these loop surveys has been modified somewhat to deal with the specific problems that we find in arid conditions like those that we find in the Kalahari Desert in Botswana. So the survey involves laying out a very large loop. The loop that we're going to be laying out is 1 kilometer long by 1 kilometer wide. It's in a square. So you lay that out. So it's a cable that you lay out in a square, and then you energize it with a transmitter, and you pump, I think it's 120 amps into the ground, which sets up an EM field, electromagnetic field. But the beauty of it is that electromagnetic field goes beyond the loop, out a further 2 kilometers, so that altogether you've got a 3 kilometer area, 3 by 3, so 9 square kilometers. So you can do 9 square kilometers on each loop. But I mean, just to set out a cable which is 1 kilometer by 1 kilometer by 1 kilometer by 1 kilometer through the bush, is quite a task. But it can be done in a day, as long as you don't have too many problems to the next one. So you can do 9 square kilometers at a time. Okay. But as you can imagine, it takes quite a while to do. It's quite hard work, and we've got a contractor who has had a lot of experience of doing these things, and it doesn't come cheap either. But I'm really looking forward to seeing the results of this. I think it's going to be very exciting. I've never done anything like this before. I don't think any of us have. So quite an exciting week setting up then. I bet you wish you were over there, don't you? Yeah, it would be very interesting, I must say. Although, of course, a lot of it's hard work and hard slog, and the really exciting stuff comes out when you process all the data. 2 or 3 weeks later, you will get some indication of the presence of a conductor, more or less in real time. But you really need to spend some time processing all the data properly and drawing up the three-dimensional model and putting any conductors that you found into the model, and from that we would expect to find conductors which would then become drilling targets. Okay. Excellent. Well, Mike Moles, the Technical Director of Kavango Resources, thank you very much for your time today, and we'll catch you up towards the end of the week, I think. Yep, fine, Mark. Thank you very much. Okay. Thank you for listening to this Stockbox interview.
For more information, interviews and videos, visit our website at stockboxmedia.com or give us a follow on Twitter by searching @StockboxMedia.